I'll back up everything
You're on.
All right.
You're on.
What if he
Yeah,
makes
okay.
a mistake?
Then I'll cover for him.
You'll deflect the question.
It's 2 weeks since the last one. Do people can anybody want to say what they remember? What was the theme of the of so far of this article, or what what they see as significance of it? Did anybody get to read the article?
Was this the challenge to Spinoza's concept of a world that is organized the way that the Eleatics believed it was?
Well, that came up. I mean, he sort of attacked that view. He warned that what this fellow was arguing for, Sturm, might lead to such undesired result. In that sense, yeah. Anybody else? Well, I think I want to just emphasize what Leibniz is actually doing is he is telling us that the universe is alive. He's the first person that I know really went out and demonstrated that. What he's saying is that there is what he calls a force in all substances. That substances are what acts, and anything that acts is he calls a substance. And then he says that the association of a substance with matter is a kind of a unit, and he calls it the monad. And he says that this thing is alive. Now, in terms of biology, he goes farther. He says living things. See, he said living things are machines. Living things are machines, which are machines down to their infinite smallest part. No matter how you subdivide them, you keep getting machines, and each machine is what he calls a corporeal substance. It has a monad associated with matter. So this has enormous implications, and this was a revolution in metaphysics. This gave you a way actually out of all the paradoxes that come from a deductive system of thought, which inevitably generates paradoxes. You saw in the Parmenides, and this guy Sturm is in a debate with another guy who's asserting that there are intelligences which actually govern nature. There are intelligences in nature which govern nature, and he doesn't like this. The guy doesn't like it because he thinks it's impious, and of course Leibniz does also. But on the other hand, Sturm, who he's responding to, is all caught up in these paradoxes. He can't get any place in his thinking. He's not willing to say that substances are acting, that there's anything that in matter other than pure passivity, and that he says creative, what he calls corporeal substances are not able to cannot act on their own, and so he's and also Leibniz said, well, the idea of he said if you have souls humans have souls, and we say maybe animals have souls. Why wouldn't increase the perfection of the world to propose that all things have something analogous to a soul and a capacity for innate capacity to act? And so this is I think that, and then he emphasizes this thing we're going to get into, and I think we should hopefully we'll have time to get started on that. We may not have time for that, but he says at the beginning there that he says the laws of nature themselves are metaphysically determined. Now, there's a reason why the laws of nature are as they are and not some other way. And one of these wonderful laws that he found out is that what he called the quantity of force, active force, is necessarily conserved. And see, and it turns out it's what he calls live force, or mv squared, okay? Mass times velocity squared. Now, the Cartesians said that mass times velocity, what they call the quantity of motion, is conserved. And what Leibniz said, look, motion is not real. How do you know? How do you necessarily know which body is in, which bodies are in motion and which just appear to be in motion? And he says that what you can do is assign a cause. If you understand what's causing the motion, then you might be able to. But otherwise, you can't. And the question is, what actually causes motion? And so Descartes and people who followed him were governed by things which are unreal. Motion is not, he said, in itself it's not real, and that was true even of people. The best minds did not really think in terms of getting at the cause of things. Like, one of the things that they began to study in the 1660s and make some sense out of was collisions, what goes on in a collision. And for elastic collisions, Huygens and a number of British people came up with the idea that mv squared is conserved in a elastic collision. But as Leibniz pointed out, not all collisions are elastic. What if things come together and they're just smushed together, and so all the motion is wiped out? How do you need it? In other words, you want a principle that covers all. It actually gets at the cause. And so what he actually is saying is that there is in this active force is in all things, and so what happens in a collision, if you have an elastic collision, what's happened is that nothing is really directly communicated from one body to the other, but it becomes an occasion for them to respond with this active force that's within them. So that's quite and Huygens didn't have that really, because he wasn't thinking in that way. None of these other people were thinking in that sense. And the idea is that, fundamental idea is that if you think of substances, that one substance cannot directly cause something to flow into the other. The monads do not interact that way. As he comes up, you'll see, he comes up with what he calls the pre-established harmony. And it sounds like, it sounds like a quaint old idea. But you think about it, what governs the refraction of light so that it follows the quickest path, as it goes from one medium to the other? We don't know. We have no idea. I think that's a good case of pre-established harmony. It's something about the universe as a whole that makes that happen. That's, at least that would seem to me, that that's something like that. And also, we were just discussing a while ago that in this case of refraction of light, that whatever determines that must act faster than light. It must be of a higher order. Okay, so I think that's something Lynn has talked about, about absolute time and God's time, and he'd given examples, of relation of galaxies, things go on between galaxies which are, hundreds of light years apart, and how do they interact within actual time. But I think this is a case, very simple case, which I think it sort of meets that.
You're saying that's a case in which something. You're saying that case between the galaxies is an example of that, where there's something higher and other?
That's what Lynn gives as an example in the article in Absolute Time. If anybody wants it, I have a copy. I don't know, people may not have saved this particular article, but I think, you have any thought about that, Phil?
this thing about yeah, I mean, I think there's a lot that you have to get at. I think the point you're making about the refraction of light, because in a way it's a different thing altogether than thinking about going, something going over a certain distance.
Yeah.
And you say, well, it's instantaneous or it's finite. But the issue here is if there's something that governs a principle,
Yeah.
can move faster than the speed of light, it governs the universe.
Yeah.
So
Okay.
as soon as you carry out an action
Uh-huh.
that in a sense calls that principle into being, or
Uh-huh.
into action, then you're dealing at an entirely different level. And there may be things that affect relations amongst planets and galaxies and so on and so forth that are of a principle, it's like this thing of non-locality, that really is something that's moving faster than the speed of light, but in a funny way, the concept is also totally different. The kinds of things that Einstein is talking about wouldn't apply apply differently. It's a higher level because principles are different than events.
Mm-hmm. So we'll be getting into shortly after this. We want to go into this question of how he came up with this idea that the conservation of force we call it live force, because then go through actually how he demonstrated it. Because people didn't generally believe him. It seemed, you'll see, it's a very straightforward demonstration, but people did not accept it. Most people did not accept it. So anyway, so why don't we just continue with this argument here, the number 11. Does somebody want to read that? Raise it up.
It is indeed true, however, that bodies in themselves are inert if this is understood in the right sense. Namely, insofar as what is assumed for some reason to be at rest cannot impel itself to motion, or suffer being impelled by some other body without resistance, any more than it can of its own accord change the degree of velocity or the direction which it once has had, or suffer such change from the outside easily and without resistance. So it must be admitted that extension, or the geometric nature of a body, taken alone, contains nothing from which action and motion can arise. Indeed, matter rather resists being moved by its own natural inertia, as Kepler has fittingly named it, and is thus not indifferent to rest and motion, as it is popularly interpreted to be, but strives toward motion with an active force proportional to its magnitude. Hence it is in this passive force of resistance, which involves impenetrability but something more, that I locate the concept of primary matter or mass, which is everywhere proportional in a body to its magnitude. And hence I show that far different laws of motion follow from it than would be the case if the body or matter itself possessed only impenetrability with extension. And just as there is a natural inertia opposed to motion in matter, so there is in the body itself, and indeed in every substance, a natural constancy opposed to change. This view does not justify those who deny action in things, but rather opposes them. For as certain as it is that matter in itself did not begin motion, so certain is it also, as the well-known experiments on motion arising from the impact of a moving body also show, that taken by itself, a body retains an impetus and remains constant in its speed, or that it has a tendency to persevere in the series of changes which it has once begun. Now, since these activities and entelechies cannot be modes of primary matter or of mass, which is something essentially passive, as the judicious Sturm has himself clearly recognized, as I shall show in the next paragraph. It can be concluded that there must be found in corporeal substance a primary entelechy, or first recipient, of activity. That is, a primitive motive force which, superadded to extension, or what is merely geometrical, and mass, or what is merely material, always acts indeed, and yet is modified in various ways by the concourse of bodies, through a conatus or impetus. It is this substantial principle itself which is called the soul in living beings, and substantial form in other beings. And inasmuch as it truly constitutes one substance with matter, or a unit in itself, it makes up what I call a monad. For if these true and real unities were dispensed with, only beings through aggregation would remain. Indeed, it would follow that there would be left no true beings within bodies. For even though there are atoms of substance, namely my monads, which lack parts, there are no atoms of mass or of minimum extension or any last elements, since a continuum is not composed of points. Furthermore, there is no being that is greatest in mass or infinite in extension, even if there are always things greater than any given things. There is only a being greatest in intention, of perfection, or infinite in power.
Yeah, well, I just want to say a couple of things here. According to Richard Arthur's translation of the entelechy refers to something that seeks perfection. Okay, so I think that's one thing. Then he's saying, see what he's saying, he's building up his case here for why there's something in matter beyond extension and mass. In other words, there's a substantial element necessarily. He's defining the paradoxes of an inductive deductive system. So, okay. Second thing is here he's saying that bodies are not real; they are phenomena, and it took him quite a while to come to this conclusion. He's not the only one who said that. You know, Spinoza said that, but then he drew conclusions from that that Leibniz did not accept. Because Spinoza said you really can't. He said Spinoza drew the conclusion that everything is really just one substance, and Leibniz did not accept that. And part of Leibniz's argument is that he says a continuum is not composed of points. In other words, he has this. Actually, you can just put up this other picture of the let's see, from the labyrinth of the continuum. Just show that. See, this thing he wrote in 1698, this thing we're reading. Keep going. You can stop. Let's see. Okay. Basically, what he's saying is that if you think of all the points on the vertical and draw lines through them across the diagonal, you can readily show that they're the same number of points apparently in the diagonal as in the vertical, and that's a paradox. That means that lines cannot really be. There's a little more to the the argument. I don't know if we need to go through that, but that's basically saying that you run into a paradox if you want to say lines are made up of points, and that's actually, this is in a dialogue from 1676 when he was working through what he called the labyrinth of the continuum. He hadn't got out yet, but this was an important step. It's really worth, if you have the time, going through some of the things he did. It's like Kepler. He an enormous amount of things that he wrote, mostly for himself, were not published until recently, where he's going through his thoughts, on how you resolve these questions. At the same time, he's developed the calculus, which is extremely important, because in the calculus he's talking about things which are as small as you want them to be, but not infinitely small. So he's using the idea of the infinite in a certain way, and so that very much is a part of the way he thought about these physical problems. It was all part of one, you could say, multiply connected thought process that he was research that he was engaged in, and out of that came this stupendous discovery about the solution to the whole labyrinth was that really this idea of the going beyond the deductive system into this idea of the active force, and you'll see that a little bit very shortly when you see how he refutes Zeno's paradox, because this guy is going to use Zeno's paradox. So we can go back to where we were, number 12. So it wants to read it.
I observe, however, that in his apologetic dissertation, the famous Sturm has undertaken to combat a moving force resident in bodies by means of certain arguments. Quote, I will show abundantly, he says, that no corporeal substance is capable of any active moving power. Unquote. Though I do not grasp what a power can be which is not actively motive. He says, however, that he will use twin arguments, one from the nature of matter and body, the other from the nature of motion. The former reduces to this: matter is by its nature an essentially passive substance, and so it is no more possible to give it an active force than for God to will a stone, while it remains a stone, to be alive and reasonable. That is, not to be a stone. In the next place, the things we assume in body are only modifications of matter, but a modification, this I admit is excellently expressed, of something essentially passive cannot make it something active. But to this it is easy to make the following reply from the point of view of the accepted as well as of the true philosophy. Matter may be understood as either secondary or primary. Secondary matter is indeed complete substance, but not merely passive. Primary matter is merely passive, but not a complete substance. There must be added to it a soul, or a form analogous to the soul, a first entelechy, that is, or a kind of nisus or primitive force of action, which is itself the inherent law impressed upon it by divine command. I do not expect this famous and brilliant man to shrink back from this opinion, since he recently defended the view that body is composed of matter and spirit, except that spirit is not here to be taken for an intelligent being, as is usually done, but for a soul or a form analogous to the soul. Neither is it to be taken for a simple modification, but for something which perseveres and is constitutive and substantial. This I customarily call a monad, which contains perception and appetite, as it were. The accepted doctrine, which is consistent with scholastic teaching, favorably expounded must therefore first be refuted if the argument of the famous man is to have force. Similarly, it is clear from this that we cannot concede his assumption that whatever is in a corporeal substance must be a modification of matter. For it is well known that according to the accepted philosophy, there are souls in the bodies of living beings, which are certainly no modifications of these bodies. For though the learned man may assert the contrary, and seem to deny the dumb animals all sensibility in any true sense, and a proper soul, he cannot assume this opinion as the basis of his demonstration until it has itself been demonstrated. I believe, on the contrary, that it is so consistent neither with the order nor with the beauty or the reason of things that there should be something vital or imminently active only in a small part of matter, when it would imply greater perfection if it were in all. And even if dominant souls, and hence intelligent souls such as there are in men, cannot be everywhere, this is no objection to the view that there should everywhere be souls, or at least things analogous to souls.
John Smith souls.
Okay, just put up for a minute Zeno's paradox, okay, the handwritten thing I had, so people see that. Then we'll go on to the next one, because he's gonna be if everything, when it occupies an equal space, is at rest, and if that which is in locomotion is always occupying such a space at any moment, the flying arrow never moves.
Wait, read that again.
If
I
ev-
was
All right,
distracted.
make it smaller, we can see.
If
better.
everything, when it occupies an equal space, means a space equal to itself, is at rest. And if that which is in locomotion is always occupying such a space at any moment, the flying arrow never moves. Now, of course, what is a moment? You see, we come back to this thing with the line and how many points.
Right.
The idea that you can't say how many points there are on a line also raises question about, can you talk about moments in time? Okay, so this is a very important, anyway, so let's see how, but isn't it interesting, here's Zeno's paradox, 2,000 years later. People are still struggling with it because they're caught up in a deductive system of thought. And that's why these things always keep coming up. You get yourself completely entangled in this. You're in the labyrinth, So anyway, so somebody want to read number 13?
The second argument, which the illustrious man takes from the nature of motion, seems to me to be no more necessarily conclusive than the first. Motion, he says, is merely the successive existence of the thing moved in different places. Let us concede this for the present, though it is not entirely satisfactory and expresses the result of motion rather than what we call its formal reason. However, it does not hereby exclude a moving force. For in the present moment of its motion, a body is not merely in a place of the same size as itself, but also has a tendency or urge toward changing its place, so that its future state follows from its present one per se by the force of nature. Otherwise, the body A, which is in motion, would be no different at the present moment, and therefore at any moment whatever, from the body B, which is at rest. At rest, and it would follow from the opinion of the distinguished man, if it is opposed to mine at this point, that there would be no way whatever of distinguishing between bodies, since there's no basis for such a distinction in a plenum of mass, uniform in itself, other than that which concerns motion. This view would thus also have the further effect that there could be absolutely no variation in bodies, that everything would always remain the same. For if there's no difference between any portion of matter and another portion equal and congruent to it, which the illustrious man must admit, because since he's destroyed active forces or impetuses and all other qualities and modifications except for existence in this place, and successively some future existence or other, all qualities and modifications have been removed. And furthermore, if the state of this matter at one moment does not differ from its state at another moment, except through the transposition of equal and congruent portions of matter which agree in everything, it obviously follows that because of the perpetual substitution of indistinguishables, the state of the corporeal world can in no way be distinguished at different moments. For the denomination by which one part of matter is to be distinguished from another, that is a future one, would be purely extrinsic, namely, that it will be in one place or another in the future. In the present, there is in fact no distinction. Indeed, neither can one be assumed with any ground in the future, because even in the future there will never be available any present distinction, since there will be no mark whatever by which one place can be distinguished from another, or one part of matter from another in the same place, by the hypothesis of such a perfect uniformity in matter itself. It would also be vain to have recourse to figure in addition to motion. For in a perfectly similar, undifferentiated, and filled mass, there can arise no shape or limitation or distinction of different parts, except through motion itself. I always think this is if therefore motion contains no distinguishing mark, it can also bestow none upon figure. And since everything which is substituted for a prior thing must be perfectly equivalent to it, no observer, not even an omniscient one, will see even the smallest indication of a change. And so everything will be the same, as if no change or differentiation had taken place in the bodies, and no reason can be given for the diverse appearances which we experience by sense. This would be as if we assumed two perfectly concentric spheres, perfectly similar, each to the other as wholes as well as in their parts, the one included in the other, so that not even the slightest gap existed. Then, if we assume the included sphere to revolve or to be at rest, not even an angel, not to say more, could observe a distinction between the states of the two spheres at different times, or have any criterion by which to distinguish whether the included sphere is at rest or turning, and according to what law of motion. In fact, not even a boundary between the different spheres could be defined because of the lack at the same time of a gap and a difference, just as the motion could not be recognized solely because of the lack of a difference. Hence, we must hold it for certain, even if those who have not penetrated sufficiently deeply into these matters may not perceive it, that such things are foreign to the nature and order of things, and that there is no perfect similarity anywhere. This is one of my new and most important axioms. The consequence of this is also that there are to be found in nature, no corpuscles of extreme hardness, no fluids of greatest thinness, no universally diffuse subtle matter, no ultimate elements such as some thinkers call primary and secondary. It is because Aristotle had seen something of these principles, I believe, that he concluded, he being, in my opinion, more profound than many people think, that there is needed some alteration besides change in place, and that matter is not similar to itself everywhere and does not remain invariable. But this dissimilarity or diversity of qualities, and this something about this alteration, which Aristotle did not adequately explain, comes from the different degrees and directions of the impulses, and therefore from the modifications existing within the monads themselves. I think we understand further from these considerations that something must necessarily be assumed in bodies other than a uniform mass and its transportation, which certainly changes nothing. Of course, those who hold to atoms and a vacuum at least diversify matter somewhat by making it divisible in one place, indivisible in another, full in one place, with intervening spaces in another. But a long time ago, after ridding myself of youthful prejudices, I saw that we must reject atoms and a vacuum. The famous man adds that the existence of matter through different moments of time is to be ascribed to the divine will. Why not then, he asks, also ascribe to the same being the fact that it exists here and now? I replied that this is undoubtedly due to God, as are all other things insofar as they involve some degree of perfection. But just as that first and universal cause, which conserves all things, does not destroy, but rather supports the natural permanence of a thing which comes into existence, and the perseverance in existence once bestowed upon it, so this same cause will not destroy, but rather confirm the natural efficacy of a thing which is set in motion, and the perseverance in action once impressed upon it.
So what do people think of this mode of argument of Leibniz?
Well, I mean, this idea that there's something in mechanics besides just matter and extension,
Yeah.
I think he's just sort of drawing it out because, you know, because it is the only thing that's going on when something moves. Is that it's basically the same matter, and the only difference is a difference in position.
Yeah.
And he just doesn't think so. I mean, that's one of the things. He just doesn't.
Yeah, what he's saying is just a blah, unless you have something he's saying intrinsic to the
There's something more fundamental.
particles that differentiates them from within them. Otherwise, you can't really distinguish them. So again, he's introducing you, the observer. Okay. That's science is subjective. I think that's an implication of this that he brings up in different areas, even comes up in terms of the way he talks about the calculus. So I think this is, and then his idea of it comes up again when he talks about what makes things similar. Definition of similar things are which you cannot tell apart from their size. So again, the observer is involved in this.
Just comment. Since he says, now I adopt this point of view as my personal philosophy, i.e.
Be louder. You got to be loud. I don't hear you.
Sorry. As we were reading out loud on the top of that page, paragraph, he says, I have now gone through this process and now have adopted this point of view as my personal point of view.
Yeah.
Which, okay, reflecting. It sounds so Kuza that when Kuza said, if you're drawing something, a radius of a line, and another radius of a line, even though you're putting ink to paper, this is my elaboration, the human creation can never make perfect lines be absolutely equal. Kuza expressed that as a phenomena of anything you create, that one line will not be absolutely the same length as another. That's a live argument that Kuza uses. Okay? Now here's Leibniz as saying a circle existing within another circle, all right, could exist even though you see no differentiation at all. You don't see nothing that you can measure. But a circle absolutely within another circle and existing is a concept, okay? All right, which is higher than trying to look in a microscope or atomic microscope to see a difference in can you see a circle inside another circle. It's a concept, all right? So it's not sense perception. It's very much like Kuza, when Kuza does a argument to show you cannot man-made straight line compared to another straight line can never be perfect. You get atomic microscope, you find one was slightly bigger than the other. Or you draw it on a piece of paper with black ink, you find that you stop one short than the other. That argument Kuza wages and superseded by concepts that are valid.
Well, I think this is what Leibniz does say. I read this a long time ago. He said that no two things are alike, and it's determined by something intrinsic to them. It's not some accidental appearance. Okay, that no two things can be exactly the same. Otherwise, they wouldn't. They would. It's sort of what he called it the identity of indiscernibles. Okay, so that's he's actually. I think this is what he's going through there about how without this intrinsic force that you can't tell things apart. So it's the same kind. It's in principle. I think it's the same argument as Kuza is making. Well, he's making it around. He's specific around the question of force, which is not, you know, it's not something that Kuza had. And Margaret, you want to say?
Yeah, when I was reading this, I'm like, this is kind of like what we addressed within the last couple of weeks, where if you've got a circle resting on a straight line,
yeah,
and you've got, or let's say you've got a circle and a tangent to that circle, all right? That point of tangency is sort of pregnant with either circular motion or, you know, straight line motion. And there's something, you can't just sort of look at the thing there and tell what it is. You have to actually, you know, you have to actually look at the entire thing. Because although they're the same point, they're not the same point. One's gonna go that way and the other's gonna go that way.
He's refuting this guy Storm, right?
Yeah.
Who's basically trying to say that that motion doesn't exist in matter. Isn't that what this guy Sturm was saying? That motion.
You mean that the second point about
that motion doesn't exist in matter, that it's external to matter. Is that what he's refuting?
That's what it sounded like earlier.
Sorry.
Yeah.
Yeah.
That's what he said earlier.
He's saying that this guy Sturm is trying to claim that motion doesn't exist in matter.
There's nothing intrinsic in matter.
Right.
That accounts for motion.
But then he shows that would lead to this paradox where you wouldn't be able to tell anything from anything, right?
You wouldn't be able to tell things apart,
right?
Yeah.
In particularly in you know, I guess in matter you couldn't if
right.
if all the particles appeared the same and they didn't have this intrinsic motion and force within them. Yeah, I think that's what he's saying. What do you think, Phil?
Yeah. I was just trying to imagine, well, what if things could be equal? I mean, any two things. I mean, you can take the I mean, in the most extreme case, if you took human beings, if each person were exactly identical, then there would be, I mean, that's, you suddenly realize the existence of it becomes impossible. Because they would, not only would they not be distinguishable, they would be in the same place at the same time doing the exact same thing, so it would become completely pointless. And if you think of that as with almost anything, it's just, it would never have occurred to me to even, the way he arrives at this breakthrough.
Yeah.
I mean, you know, it's really fascinating, because you look at the world and say, well, obviously, no two things are identical, nothing in the physical real world could possibly be identical, but then you say, well, why is that necessary? Which is interesting.
Yeah.
Well, I think he's also establishing the idea of the monad. I'm just sort of reviewing this last paragraph here. That the famous man adds that the existence of matter through difference of moment and time is to be ascribed to the divine will. Okay, fine. Well, you know, how about the here and now? He says, I ascribe this is undoubtedly due to God. Who, he basically, yeah. In any event, he says that not only is God responsible for, here we go. Just as that first and universal cause which conserves all things doesn't destroy, but rather supports the natural permanence of a thing which comes into existence, and the perseverance in existence once bestowed on it. So I think this is the idea of the monad, something which has permanence.
Yeah.
Which is but much more permanent than any of its component parts or motion or anything like that.
Oh, he's very permanent. He says he believes that the monads are all come into existence at the creation, all the monads. The only exception, I think, is the human soul, which he says comes into existence at conception. But other than that, all the monads go all the way back. And then, conversely, they cannot be destroyed because they're immaterial. So they never, the monads never, unless God chooses to annihilate them, they never go away. And then he says that, but then people would say, well, wait a minute, you said the monad it goes with matter as a unit. So what happens to the matter? He says, well, there's this little itty bit, you know, of matter that remains associated with that monad, okay, until the resurrection or whatever. But that's his argument. And that's just very interesting, because this plays a big part in his ideas about biology. See, we've had, in terms of the organization's, you know, publications, there's been virtually nothing about Leibniz's ideas about biology, but a lot of his thinking was directly a result of particularly the microscopists, you know, these Swammerdam and Leeuwenhoek, Malpighi, these people, that he was very, very interested in their work from you know, when he was very young, and it very much informed his thinking about monads. So let's keep that in mind.
Every drop of water contains a universe of these.
A worlds within worlds.
A world within worlds.
Yeah. Yeah. So he. So some people said, you know, they took it to say, well, within the sperm, there's another organism inside it, you know, and inside of that one is his own sperm, which has within that, you know, and going back to the creation. He actually, I believe, he believed that, you know. So remember, this is all historically specific, you know.
Sure. But I mean, it's the case that what they did is they took a drop of water from a lake or something like that, and they looked at it and said, holy shit, this thing is just teeming with all kinds of life.
Yeah.
With all, you know, so, you know, and then you look at, you know, you divide that and you take one little thing and it's teeming with all sorts of other little organisms too.
Yeah.
Okay, in this general conversation, Ernie, you brought up an idea, a Leibnizian idea, that very small or very extremely small, but not infinitely small, is a concept where absolute infinite small does not exist. There are smallness
Yeah.
Very, very,
You
very
can make them as small as you want.
Yeah, but a concept, an infinite process never ends. That an infinite divisibility. The concept is everything infinite divisibility. Everything. That concept is false.
That,
There
yeah,
is
you
a-
rejected that.
There is smallness, super smallness, extreme super smallness, but there's a definite limit, but not an infinite process that's endlessly endless.
Yeah.
So he's establishing, because when LaRouche used to talk about geometry, he says when you cut a cone with a diagonal, cause ellipse, there'll be a small ellipse, another slice, another ellipse, but then there'll be a moment in your construction that you have the smallest possible ellipse, you cannot go any further. All right? That there's not an infinite divisibility
Right.
in geometry with concepts. You come to a concept, it's very small or super small, but it's not an infinite process of infinite divisibility.
Yeah.
Okay? And what I heard you say in your comment, that Leibniz was talking about small, super small, but not infinite.
That's right. That's the
Right.
difference between him and you know, the fakers, you know, Cauchy and the people who, Euler, you know, they basically messed up his chain, Bowdlerized. They destroyed the intention of his calculus. The idea was that the calculus in a way is a representation of the monad, in a sense, this infinitesimal of his particular kind of infinitesimal. And the thing that Eli's talking about, I remember because Lynn went through this thing with what he called it Leibniz's delta, the ultimate sort of cut, you know, that you can't make go any further with the cone.
Forbidden ellipse.
He did refer to it that
Yeah,
way as the
Carol
delta,
Flavor.
Leibniz delta. Yeah. So I guess we can. Why don't we go on? Just do number. I guess 14 and 15. That would be sufficient. Somebody want to number 14? If we have time, it's almost 7 o'clock.
I'll do 14. Many other things appear in this apologetic dissertation, which involve difficulties. For instance, what he says in the chapter about a moving globe being translated through many intermediate positions into collision with another globe, to the effect that the last globe is moved with the same force by which the first is moved. Here it seems to me that they are moved with equivalent force, but not with the same force. Since each one is set in motion by its own force, namely by elastic force. When driven back by the body striking it through this, though this may seem remarkable, I am not now discussing the cause of this elasticity, nor do I deny that it must be explained mechanically by the motion of a fluid existing in and moving through it. His remark in section 12, that a thing which cannot give itself original motion cannot continue in motion by itself, will therefore also rightly seem strange, for it is clear that on the contrary, as force is necessary to impart motion, so once the impulse is imparted, far from being needed to continue this motion, it is rather needed to stop it. Such conservation is made necessary in things by a universal cause, which this is not the place to discuss, but which, as I have already cautioned, would destroy the substance of things if it destroyed their efficacy.
Well, the people understand what he's the physical process he's talking about?
If something smashes into something and it moves.
Well, I think he's talking about a chain. He said the last globe. So it looks like a row of globes,
Oh,
which
I
are all
see.
elastic. So you hit one, and then
The last one.
force is transmitted. So he's making a particular point about elasticity, because what he's saying is that each one is set in motion by its own force. In other words, nothing is directly communicated into a monad. There's no flux or influence into a monad. It's provoked to act. It's sort of like, see, Lynn makes this point, and he has this nice section here in the article on LaRouche's discovery. He's talking about, it's the next to last page, he's talking about my proof of the monad. And he goes through, how, metaphor, that in the 3 steps, to acquiring, a Platonic idea. First there's the paradox, then there's the proposed solution, and then it's communicated through metaphor, because it's a new idea. There's nothing in the language that supports that. So in effect, you're forcing the other person with whom you use the metaphor to reconstruct the idea. So
That's
that,
the analogy with the,
huh?
that's the analogy with the physical process.
Yeah, that's it. That's what he's talking about. Then Lynn says, so he elaborates the argument. He said, this thing has been sitting under people's noses for millennia. He said, but this is the proof of the monad. And he elaborates it. It's a complex thing, but it's elementary in a sense. But the point is, this is his proof of the, and then he goes on to say, we as individuals are monads in a kind of a continuum. We're all singularities, because we're, through our creativity, we're all singularities. So, but that's, and then you take the word educate. What does it mean? To draw out, right? Okay, that's the real idea. You elicit, you trigger the creativity of the individual. So it's a very, very, very powerful idea. I mean, we wouldn't have Lynn and LaRouche if we weren't Leibniz. He really is. I mean, this is why it's so important to go through this. Make the connection between him and. He would not have been able. He said, "I would never have been able to deal with this clockwinder paradox." You remember, if it were not had studied Leibniz, when I was a teenager, and then defended Leibniz, versus Kant. So I think this is extremely important. Anyway, do we have any more time? I don't think so.
That's time.
No.
We can read
At least we got
15
to,
because we started a little late. Why don't we read 15 because we started late?
Okay.
And we'll
Somebody want to read it?
I'll read it. These considerations make it clear further that the doctrine of occasional, I think it's
You have to go on.
the other
Oh, it's
side.
Want to read it here?
Okay.
Causes.
Yeah, I'll start over. These considerations make it clear further that the doctrine of occasional causes, which some defend, unless it is interpreted in a way that makes possible some moderations,
You didn't
as
have me copy this page, I'm sorry. I didn't-
it's right there.
I know, but I can't.
Yeah, but it's not all there.
Oh, it's not
I
all
didn't,
there.
you didn't give me the.
I didn't give it. It's
page.
my fault. I didn't give it.
Then
that
maybe we
page.
should just stop there.
No,
You want me to read it?
It's good to
Okay.
read it. It's good. It's
All right.
relevant.
These considerations make it clear further that the doctrine of occasional causes, which some defend, unless it is interpreted in a way that makes possible some moderations, as Sturm has partly admitted and partly seems to want to admit, is fraught with dangerous consequences, even if its learned defenders do not, as is undoubtedly true, intend them. So far is this doctrine from increasing the glory of God by removing the idol of nature, that it seems rather like Spinoza to make out of God the nature of the world itself, by causing created things to disappear into mere modifications of the one divine substance. Since that which does not act, which lacks active force, and which is despoiled of all distinctiveness, and even of all reason and ground for subsistence, can in no way be a substance. I am most certainly convinced that Mr. Sturm, a man distinguished in piety and learning, is far removed from such monstrosities. So there is no doubt that he will either show clearly on what ground any substance or even any change is left in things according to his doctrine, or he will extend his hand to the truth.
Okay. All right.
Yeah, sure is.
Right,
exactly. It needs
gonna
somebody to
yield.
go after Pope Francis with that boldness and rigor.
Yes, that ought to be you.
Right.
Is that it?
Yep.
Yeah, unless somebody has a comment on this. See, the importance of Spinoza. Spinoza died in 1676. Leibniz moved heaven and earth to get to meet this guy.
Uh-huh.
He was considered a heretic, excommunicated from the Jewish community and so on. But Leibniz was, he was 30 years old, and he said, this guy is saying something very controversial. I want to know what it is. So he arranged through friends of his to get to meet. He had a lengthy discussion with Spinoza, and he was very provoked by this discussion, particularly this idea of whether you can really say the world is just this one substance. So it was a very, very intense metaphysical debate that he had, and then Spinoza died 2 months later, so he was lucky he actually got to meet Spinoza, before. So.
But Spinoza was also the victim of an assassination attempt.
Oh, really?
Yeah. Supposedly, outside of the synagogue, somebody tried to knife him.
Is that related to DeWitt at all? The
I don't,
assassination?
there was a whole big battle in Holland at this point. I don't know all the ins and outs of it.
We don't know how he fit into the whole thing.
No.
What faction he was.
We do know that he knew Rembrandt.
He was a
Or
friend of Rembrandt.
Yeah.
Oh, okay.
Or Rembrandt, it appears that Rembrandt lived very close by, and it's likely that they ran into each other.
This painting of the philosopher,
Yeah,
was that him?
Some talk, there's been some, I don't know.
I have that. I owned that for a while.
Yeah.
I got that at
Some
the
people
national
think it's
conference.
Spinoza. Because it's a big joke, it doesn't look like, the idea of painting Christ as dark-haired and dark-eyed, even though that might seem to make some sense,
Right.
Was not the usual approach.
He had a
Somehow
lot
he
of-
didn't look like Middle Eastern.
Well, Rembrandt used a lot of the
Jews
in the area.
Yeah.
Since
He lived in the Jewish quarter, so to speak.
You live what?
The Jewish
Rembrandt
quarter of
lived in the
Amsterdam.
Jewish quarter.
Oh,
of
okay.
He used Jewish models for the figure.
Yeah.
Oh, yeah.
Well, he painted a lot of Jews.
Yeah.
Oh, okay.